Let's cut right to the chase. You're here to crush your computer graphics back exam, specifically X603. And we are skipping all the fluff today. Look, retaking an exam is incredibly stressful. I get it. But here's the secret. Chapter 1 is practically giving away free points if you know where to look. We're going to break down the exact, repeated exam prompts, translate the super dense textbook jargon into totally plain English, and arm you with some bulletproof memory tricks. By the end of this explainer, you're going to walk into that exam hall with absolute confidence.
So, here is our high-yield hit list for today. We've got the blueprint, raster versus random displays, frame buffer math, pixel scanning math, and finally, those exam memory tricks. Quick and dirty. Let's get right into it.
Number 1, the blueprint. These are your guaranteed points. Seriously, there is zero reason to panic about this retake. When you look at handwritten syllabus notes from students who actually aced this, a massive pattern jumps out. We aren't dealing with random out-of-the-blue concepts here. There are literally 5 specific questions that haunt this exam paper, semester after semester. Differentiating raster and random displays, calculating frame buffer size, and finding the access time per pixel. That's the core. And the sheer repetition is wild. I'm talking about the exact same theory and math questions showing up in 2068, 2070, 2071, all the way through to 2078. Think about what that means for you. It's a huge advantage. We don't have to guess what the examiners are thinking. We already know exactly what they're going to ask. You just need to know how to nail the answers efficiently. All right, moving to number 2, raster versus random displays. This is the theory heavy hitter. I can almost guarantee you're going to see some variation of this exact prompt on your paper. Differentiate random and raster display technology. When you see it and realize it's worth a chunky 4 to 6 marks, do not freeze up trying to regurgitate a complex textbook definition. Just think of it in plain layman's terms. It's really just asking for the difference between stamping a grid of pixels versus drawing with a continuous pen. A raster display is basically a giant grid of tiny colored dots, pixels, right? That light up row by row to make an image. On the flip side, a random display, also known as a vector display, doesn't mess with grids at all. Instead, it uses precise, directed drawing lines. It's exactly like how you draw on a piece of paper, moving the pen directly to wherever the line actually needs to go. Okay, so how do we lock this in your brain? Try this memory trick. Raster means rows of dots. Raster, rows. Simple. And random or vector means vrooming straight lines, like a car zooming directly from point A to point B. Raster equals rows of dots, vector equals vrooming lines. It sounds a little silly, but honestly, phonetic anchors like this are absolute lifesavers when you're sweating in an exam hall. Let's hit number 3, frame buffer size math. It's time to crack the calculation. This right here is where so many students leave incredibly easy marks on the table. A question like, what is the size of frame buffer required to store SVGA with 24-bit true color video of 10 men without compression sounds like a total nightmare. It's packed with acronyms and numbers designed to make you panic. But guess what? It's literally just asking you to find 4 basic numbers. The secret sauce is just a simple extraction formula. Just pull those 4 variables out of the word salad and multiply them together. Step 1, pull the resolution. SVGA usually implies a standard like 800 by 600. Step 2, grab the color depth. Here, it's 24-bit. Step 3, find your frames per second. And step 4, extract the total time, which is 10 minutes in this case. Once you've rescued those 4 elements from the text, you just multiply the whole shebang together. Boom, there's your memory size. Now, examiners love to switch up the wording to try and trip you up. But if you keep a mental cheat sheet of these recurring variables, you'll spot the data instantly. 24-bit true color, that's your color depth. SVGA system, there's your resolution cue. 60 FPS refresh rate, that's your frame multiplier. And 10-minute video, that's your time. Spot the numbers, convert them into standard units if needed, and multiply. Easiest points of your life. Moving right along to number 4, pixel scanning time math. Let's get over the refresh rate hump. This is the second recurring math problem you absolutely have to master. This prompt is straight out of the 2070 paper, how much time is spent scanning across each pixel during screen refresh on a raster system with a resolution of 1024 by 768 and a refresh rate of 60 frames per second. Again, sounds super technical, right? But it's just another straightforward extraction exercise. Even if they threw you a curveball, like giving you screen dimensions in inches and pixels per inch, the core task hasn't changed at all. They're just wearing a different disguise. You just add one tiny extra step. Multiply the inches by the pixels per inch to get your total resolution. So 12 inches times 100 is 1200. 10 inches times 100 is 1000. Boom! Your resolution is 1200 by 1000. It's the exact same problem. So here is your foolproof 3-step trick to nailing this every single time. First, calculate your total pixels by multiplying width by height. Second, take that huge number and multiply it by the frames per second. And third, just put a 1 over it. Seriously, divide 1 by that total number. That tiny fraction is your access time per individual pixel. Find total pixels, multiply by frames, put a 1 over it. You've got this. And finally, number 5, your exam memory tricks. If there was ever a time to take some mental notes or actual screenshots, this is it. We've boiled all this down to the absolute bare essentials. First up, lock in your theory points with that phonetic anchor. Raster equals rows of dots. Vector equals vrooming lines. When they ask you to compare display tech, let those words trigger the image of stamping a grid of rows versus drawing one continuous zooming path.
Second, secure that frame buffer size math question. Just remember the multiplier flow. Resolution times color depth times FPS times time. Hunt down those 4 pieces of data, multiply them, and you're golden. Don't let the acronyms intimidate you.
And to guarantee those final pixel scanning math points, put a 1 over your total pixels and frames. Access time equals 1 divided by the total pixels times the refresh rate. It's an unbreakable formula no matter how they try to hide the resolution in the prompt. So, we've looked at the evidence, we've decoded the jargon, and we've built your exam hit list. With all these specific structures and memory tricks fresh in your head right now, what is actually stopping you from walking into that back exam and totally owning it? You've got the tools. You know exactly what they're going to ask, so are you ready to go out there and secure those guaranteed points?